I'm going to upload this video about the analytical method developments for how to start the developments. So when we are going to start any method developments, before starting the development, we have to think, we have to keep something in some points in our minds that we need to aware when starting the development. First thing is the goal of setting of analytical method. So when we are starting the development, so our goal should be clear. We have to understand what is the requirement of the method. So sometimes method is required for the IPC analysis, sometimes method is needed for the related substance analysis, or sometimes method is needed for the cleaning methods, and sometimes we are doing the method for the different vendors. So when we are doing the method developments, before starting of the method developments, we should be aware that what is the scope of the analytical method and who are the end user of the method. Suppose when we are doing the development for of the IPC method, then we have to consider that method runtime should not be more. Second thing, when we are doing the development for any case sims raw materials, then we have to consider that what are the facilities that our vendor is having. So based upon the facilities, we have to develop the method. What is happening sometimes if you are developing the method by using the CAD detector, and there is a possibility that detector vendor is not having. Second, end user information. So who will be use the method? When we are developing the method in analytical R&D, so we can see we are having maximum facility. But we have seen in some quality control laboratories or vendor side quality control laboratories, this facility will not be there. So all these points we need to consider before starting the method developments. Now, after setting this information, we have to see what are will be the good characteristics of a analytical method. So based upon these things, we have to finalize the our goals. According to we have to set the method. So after so we have to see the things accordingly. When we our method developed, so we should having the all information like RF, what is the RF of the different impurities and what are the RRT of the different impurities in the method. And we should have strong justification about what buffer we are using in the analytical method developments, what gradient we are using in the method developments, and what is the sample temperature. So during development, we should have the information about the sample solution stability, or when you are finally choosing any wavelength, we should be aware why we are choosing the particular wavelength. Next thing, availability of technique at the user end. As discussed earlier, we should be aware that whatever the end user of the methods, whether they are having this facility or not. Last point, simplicity. Our method should be simple so that everyone, every new person can do the analysis by using the method. Ruggedness, method should be ruggedness, should have the ruggedness, means the results of the analysis should not be changed from day to day. And if method results are changing day to day, then we can say our method is not rugged enough. So during development, we have to generate the data of different columns, different users, different systems, so that problem will not come in the future. Robustness. Robustness means we have to have the information if some parameters of the methods are changing during lab to lab. Sometimes what is happening when analyst is making the mobile page, or when system analyst is using different systems are having different system volumes. Based upon that, our method should be regard of different system and different users. Initiation of the method development. So when we are starting the analytical method development, we have to do the literature search. Sometimes we can get literature of the similar compound. Based upon that, we can finalize our we can get some idea that whether this method can be used for our purpose or not. So that can give some clue to us before starting the developments. Before starting the development, we have to see the what is the ROS of the our compound. When we are doing the development for any molecules, we have to see what is the ROS of the compound, what are the starting material of the compound, what could be the degradant impurity in that method. So that information we have to check, and based upon that we have to finalize the list of the impurities that could be possible in the method, and we have to check the specificity of the method by using these impurities, and our method should be enough capable to determine these impurities. Next point, criteria. You have to set the goals of the any good methods. Methods will be enough robust and simple and rugged, so that it gives the constant result in different laboratories. When after getting the information from the literature, we have to finalize, select. Suppose sometimes what is happening, we are having few methods, 2 3 methods. So then we have to see the method, which method we can use in our for our compounds, and if any method, if that one having the more information as compared to other method, so that method we have to choose for the initial development purpose. After getting this information, we have to finalize the physiochemical properties of the compounds. We have to see the what is the solubility of the impurities, what are the pH of the sample solutions, and what could be the lambda max, so that the physical chemical properties of the sample and impurities we have to check before starting the method developments. That will help us to set the initial method. Selection of technique. Selection of techniques should be based upon the compound nature. If compound is volatile nature, then we have to use the GC method. But when you are using the GC method, compound should be stable, should be enough stable. If compound is not stable, then we have to see on the HPLC. When we are using the HPLC technique, that time compound should be compound should have the UV activity in nature. Means compound should have the structure that it is UV active in the nature. Now that way we can start the development. Now I will go the selection of the buffer. In the HPLC developments, there are the few things which are very important, like selection of the buffer, selection of the column, selection of the diluent. So these things, three things are very critical in the analytical development. So in this video, I will discuss only today first thing, selection of the buffer. So before starting the development, when we are starting the development, we have to choose a suitable buffer so that our maximum compounds or maximum impurities get separate in the particular buffer. Buffer is very important in the HPLC method developments. So we should be very careful before finalizing the buffer. So there are different type of buffer which are used in the industry for the HPLC purpose. Some of them are the phosphate buffer. Phosphate buffer, you can see phosphate buffer are having very different pH range. So we can use the phosphate buffer in acidic as well as in basic nature whenever is whatever the required. So if we can see phosphate buffer like case 2 before, it is having the 3 pK values. So based upon the pK value, different pK values, we can use this buffer in different range. We can use this buffer in acidic range as well as in basic range. So now I have given few important points which we have to consider before finalizing the mobile phase. So first of all, we have to select a buffer, and normally selection of buffer should be based upon the method. So when compound is having low absorbance at lower wavelength, that time we have to choose the buffer in a very careful way. Some buffers which are creating the problem at lower wavelength, so we should avoid these buffer in the development. Like acetic acid, when we are using the acetic acid in mobile phase, the UV cutoff acetic acid is 230 nm. So we should not use the acetic acid in the mobile phase when method wavelength is less than 230. Similarly, formic acid also having the UV cutoff 210. So when we are doing the method development at lower wavelength, we should not use the formic acid if method wavelength is 210. So based upon the UV of the method or lambda max of the method, we have to choose the buffer. There are some other solvents where in this table I have given the UV cutoff value of these solvents. So based upon the method requirement, we have to choose the mobile phase or buffer. In the buffer, one thing that is very important, pH. So that I will discuss in the next slide. So when before starting the development, we have to think few points. First one is the use of mobile page where all impurities are separated from each other and well separated from each other. Mobile page should not have the interference at the retention time of the impurities. So there should not be interference due to the blanks. So means you have to choose a mobile page which is not giving any interference at the impurities RT. If there is any interference at the impurities RT, then we have to choose some different buffer. Mobile page pH. Mobile page pH can be adjusted in a way that all impurities are separated from each other. So by playing with the pH of mobile page, we can separate the different impurities, and in particularly in case of the polar or ionizable compounds, mobile pH is very important. Basic there are some basic compounds which are containing amino groups. So what we have seen that basic compound is giving tailing in the HPLC development. So when we want, so the reason for the tailing is the interaction. So as we know that column is having the silica and it is having the free synol group. These free synol groups will make the hydrogen bonding with the nitrogen elements present in the compounds, and due to this hydrogen bonding, compound is giving the tailing. So if compound is giving tailing, that scenario we have to add some amount of triethylamine in the mobile phase. So by using the triethylamine, synenol group in the columns or stationary phase will become inactive and we will not get the tailing in the compounds. When our compounds is not getting written in the columns, so that time we can use the ion pair reagents. Okay, so now I will discuss about the ion pair reagents. So ion pair reagents are the compounds which are having the different ionizable groups. Like we can say ion pair are of the two types, cationic ion pair and anionic ion pair. So now anionic ion pairs like octane sulfonic acid, heptane sulfonic acid, pentane sulfonic acid, hexane sulfonic acid, these ion pair having the sulfonic acid group in their structure, and when we can use this type of compound for the basic compound, means compound containing the amino groups or hydroxyl group. So that time case we can use the anionic ion pair. So these anionic ion pairs like sulfonic acid, pentane sulfonic acid, hexane sulfonic acid can be used to retain the basic compound. So the ion pair are active only for the ionizable compounds or the polar compound. It will not work for the neutral compound. Second category of ion pair reagent is the anionic ion pairs. Means these ion pairs are used for the separation for the anionic ion pairs. These are ion pairs are the quaternary ion pairs. These ion pairs are used to separate the acidic compounds or different compounds. Normal phase. If our compound is not getting separated, then we can go for the normal phase chromatography. In the normal phase chromatography, the stationary phase is the polar, whereas the mobile phase is the non-polar. So that technique, that chromatography also we can use for the very early routing compounds. So means buffer selection is very important. So we have to choose buffer carefully during the analytical development based upon the compounds and the UV compound and the UV maxima of the method. Next thing is the role of the mobile phase pH in the separation of the compound. We have to select the mobile phase pH such a way that it should be plus minus 2 unit away from the pK value of the compound. And if the compound pK value and mole pH value, these are matching together, so that scenario, what we can get, we can observe that RT variation or area variation of the compound. So to finalize the molecular pH, we should be very careful. That should be plus minus 2 unit from the pK value of the compound. Now in this slide, I will explain how the pH will work for the retention of the compound. So I have given one example here. This is one compound here, that is acetic acid, and it is ionizing here into the plus ion into the and the acetate ion. So here what is happening, when any compound is in unionized form, it will retain in the column more, means that is having the hydrophobic nature, and when it is in ionic form, it will not retain, it will retain less in the column. So every compound, when it is in the anionic form, it will retain in the column. So we should make adjust the pH of the molecule such a way that compound should be remain unionized, then it will be written in the columns. So there is a one link between the pH of and the acidic or basic nature of the compound. For the acidic compound, we have to use the acidic pH. If you, this is the diagram here. First side, if we see when pH is lower side, then compound is having the more retention here. And when we are increasing the pH at the higher side, when we are moving the pH from 2 to 4 or 4 to 6, that time compound is retaining less in the columns and it is yielding early. And we can see here in a different way also, when we are increasing, when we decreasing the pH, the compound is retaining more. So acidic compound will retain more at the lower pH. Similarly, in case of basic compound, this green color picture is about the basic compound retention. X-axis is the retention time. X-axis is the pH of the mole phase. Y-axis is the retention time. So when mole phase pH is increasing, so RT of the compound is retaining. RT of the compound is increasing. Means for the basic compound, compound will retain at the basic side. Sometimes low value of pH also impact more. This is the one picture I written here. So here it is given in the picture A and picture B here. When molecule pH is 5.1, the last peak, that is well separated from the second last peak. But when we are keeping the pH more 5.2, when pH is a little increased, then this retention time of the second peak is getting reduced, and this is merging with the second last peak. So pH is too much important in the molecule pH. Final conclusion about here is that we have to select a proper buffer for all compounds, and that particular buffers, all impurities should be separated, and we have to adjust the pH of molecule in such a way that all impurity get separated from each other. Second things, we have to adjust the pH the molecule based upon the columns. Different columns are having different pH range. When you are using the acidic pH, so that time we have to see whether our column is having that working range or not range. So based upon the columns pH, we have to select the molecule pH. So in the next video, I will give the information how to select the how to select the stationary phase, and I will explain what is the criteria to select the column chemistry. So in this video, I present the selection of the mobile phase and the pH of the mobile phase. Hopes this video will be helpful for